So let's get started with the parabola. So topic number 2, the parabola. Now we're going to do two types here, guys. We're going to do the normal one. Remember, parabola, there are two types. There's one, the trinomial, and the one with the turning point. So we're now doing type 1 of 2, which is the trinomial. Very important. Very, very, very important. Okay, the trinomial expression. So now I'm going to say f of x. Here's the question. F of x, we're first going to do sketching. It's going to take a little bit of calculation, so I'm not splitting the board up. I'll do finding the equation after I do this. So please just bear with me. So we've got f of x is equal to x squared minus 2x minus 8. There we go. This could be any trinomial. X squared minus 2x minus 15. X squared minus 3x minus 10. X squared minus 8x minus 20. X squared minus x minus 6. X squared minus x minus 12. Makes no difference. It's a trinomial expression. We're going to follow the same principle. So we're going to do the same method. We're going to start off using the same method as we use for the straight line graph. Let x equal to 0 solve for y. Let y equal to 0 solve for x. So here goes. Let x equal to 0. Let x equal to 0. What do we have? 0, 0. Remember, 0 squared is 0. 0 times minus 2 is 0. What am I left with? Minus 8. So therefore y is equal to minus 8. So when x is 0, y is minus 8. So what did we just find? We now found our y-intercept. We found out where that parabola is going to cut on our y-axis. Let x equal to 0, solve for y. Let y equal to 0 now. So now give y a chance. So what do I have? X squared minus 2x minus 8 equals to 0. What is that? Isn't that a trinomial expression? Isn't that a quadratic equation? And what did I tell you earlier in our previous episodes? If you do not know how to factorize a quadratic, you won't be able to sketch a graph. That's why I showed you how to factorize a quadratic equation. So now we break this up, equal to 0. X, factors of 8 to give me a 2, 4 and 2 minus plus x is equal to plus 4. I'm sure you know how to get that by now. Or x plus 2 equals to 0, x is equal to minus 2. So what do I have here? I've got my y-intercept, I got my two x-intercepts. So this is step number 1. That's step number 2. Step number 3. It's only 3 steps before we sketch the graph. We need important vital information from the equations. What did I need? I needed my y-intercept. How did I get my y-intercept? Let x equal to 0. I needed my x-intercepts. How did I get my x-intercepts? Let y equal to 0. I now need the turning point of the graph, and the turning point is going to be given by minus b over 2a. Now I know your teacher showed you a different way, and I'm going to show you an alternate method, right? I want the turning point in coordinate form. I know what your teachers show you at school. They show you x is equal to minus b over 2a. Then take the minus b over 2a, plug it back into the original and get your corresponding y. Yes, you can. I'm not saying you can't do it. But I'm saying that if there's a formula for x, don't you think there must be also a formula for y to get my turning point? Common sense? So let's see. From our quadratic formula, to get the y value of our turning point, we use 4ac minus b squared over 4a. There we go. And that will also help you to determine the range of the graph. Now why do I give you this formula? Because if the question didn't ask you to find the turning point and they just asked you to find the range, you would still have to go and say x is equal to minus b over 2a, plug it into the original to get the y value. I am saying no. If the question only asks you for the range of the graph, you know range is the y value. You can immediately go into this formula, substitute your values and get the range directly from using this formula. So that's the formula for determining the range. The range is also your minimum or your maximum from your parabola. So let's now substitute minus b over 2a. We now go back to the original. Minus b minus my b value minus 2 over 2 into my a value here is 1. Then I've got 4ac minus b squared minus 2 squared over 4a. This will give me 2 over 2, which is 1. 4 times minus 8, minus 32, minus 4, minus 36 over 4 is minus 9. And there we go. That is the turning point of the graph. So what do I have? I got my y-intercept, I got my x-intercepts, I've got my turning point. What do I do now? Sketch the graph. Obvious. So let's go to the graph. There's your graph. Okay, let's go to your two x-intercepts. X is equal to 4, x is equal to negative 2. 1, 2, 3, 4. Or x is equal to negative 2. There we go. What's your y-intercept? Negative 8. So let's say minus 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's negative 8. And what's your turning point? 1 and negative 9. So we go to 1 on my x. You always put a dotted line through the x value, right? And because that's also your axis of symmetry, that is going to split the graph into a mirror image. So 1 and negative 9. So there we go. So that's 1. That's your turning point, 1 and negative 9. Now we know if the sign here in front of x squared is positive. If it's positive, it's a smiling face. If it's negative, it's a sad face. So it's positive, it's a smiling face. That means this graph will be a smiling face. So all we do is we go and we join the dots. There we go. Make sure that it turns. It must be parabolic. Parabolic means it must be curved. It cannot go like that and like that. Please do not ever do that. You will get it wrong. That's a different graph altogether. So here we go. That is your parabola. And if you want to, you have to, you call it graph F. And there you go. The graph like this is worth 6 to 8 marks. Please make sure you know it. Okay, so that's the process. Let x equal to 0, solve for y. Let y equal to 0, solve for x. Turning point formula, minus b over 2a, 4ac minus b squared over 4a. Take those points, plot it on your graph, join the dot, and Bob's your uncle.